Hello everyone, my name is Matthew Shiroma, a cloud engineer at Nebulaworks. My job is implementing new software in existing systems and automating the deployment of cloud infrastructure. Before we begin, let me ask you this question. Have you considered why you and your team wants to use a service mesh? If not, you have come to the right place. I will be going over what one must understand before committing into using a service mesh for your solution. While its advantages are clear in theory, there is more to understand about your underlying architect and tools. Service meshes do not solve every solution's problems. It can only be as helpful as the operator using it, meaning you. By building an understanding of the concepts behind it, one can then fully understand a tool's potential and weaknesses. By watching this video, I presume you're interested in jump-starting the adoption of a service mesh for your applications. As such, there are three core ideologies you'll need to address beforehand. Your app's hierarchy, your app's scope, and your app security. If there are any topics mentioned in this video that you want to learn more about, such as service meshes and microservice architecture, I have included some links in the description below. At the end of the video, you will be equipped with knowledge that will help push your company's application to the next level. So, let's get started. I want to go over the first question you should be asking yourself when considering using a service mesh: your app's hierarchy. When I say this, I am addressing how your application is structured. Is it all grouped together as one self-contained software, or is it a group of associated independent services? If your answer is the former, a service mesh may not be the best option for your solution. The reason being is because in this type of application, your layers, or your services in this case, they already have established communication protocols between each layers. In fact, you could say it's hard-coded in the application's logic. So, in other words, because of this hard coding in between each layer, having an external service such as a service mesh to handle the communication, it isn't exactly a good idea to have in this sort of case. So what if we add, let's say, another service into this application? Would having a service mesh be justifiable in this case? Not really, but in this sort of case, there will be exceptions, but we're not going to go over that right now. That would be in another point. But just for the sake of simplicity, because of the way the communication is already established between each layer, having a hard-coded line in this case would probably be the best. So now suppose our application is a group of associated services instead of one big package. In that case, would a service mesh be helpful in this case? Yes. In fact, you probably should have the service mesh in that purpose. The reason being is because how would you have your services be talking to each other in this sort of case? So let's say service 1 is a server, a front-end server maybe, and service 2 is a database. We could have both of these be connected to each other by a hard-coded line, but that brings up another issue of how would we bring in new services into this application and have them communicate to each of the other services. Should we do another hard line like before? We could, but then again, it would get more and more complicated if you add more and more and more services. So if we instead introduce a service mesh in this case, we can then instead have all of our communication be handled via service mesh because one, we didn't have an innate way of having our services connected to each other, so we don't run into this issue of having hard-coded lines at the very beginning. And it also abstracts out our application's communication because of how one of the advantages of a service mesh is the globalization of communication. So because of this abstraction, our services can now focus more on doing their own functionality and let the service mesh in this case handle all the communication within the application. So in other words though, depending on how your application is structured, a service mesh may or may not be the best option. So if you're unsure about it, always ask your lead architect about how your application works. The second point I want to make when considering a service mesh is your application scope. When I say scope, I'm referring to how your application will have a much higher user base as well as updates post-development. Depending on how your application is structured, the amount of overhead when it comes to doing said tasks would vary greatly. So in the case of a monolithic app, monolithic being your application is all in one sense. And when I say scope, I'm referring to how your application will have a much higher user base as well as updates post-development. Depending on how your application is structured, the amount of overhead when it comes to doing said tasks would vary greatly. So in the case of a monolithic app, monolithic being your application is all in one standalone independent package. Updating and scope would be very different as opposed to what a microservice, an application where all your services are loosely grouped together, but they're all independent in some form, would vary. So when we're updating our monolithic application, we would add a service to our layers and hard code our communication line to the other layers. Would a service mesh help and streamline this process? Well, if you remember what we said earlier, because of the way we would have to redeploy our application once we add another service in order to get that connection up and running, because of how we hard-coded our application, having an external service wouldn't be too much help here. So, in other words, we already have a way of updating our application in our app, even though it's a little slow at sometimes. So, what about scope? So, let's say we have our monolithic application in a zone where there's two instances, by the way, being servers that host our application are in. And we want to have each of these applications sort of synced up together because we have an internal database or something, whatever. How would we go about syncing the data in between these two instances? We could do a hard line in between each of these, which would be okay. But then what would happen if we were to expand our application even further and have maybe, let's say, another zone of where we have more instances of our application residing there? How would we go about syncing the data between these zones, as well as between each other at that point? What we could do is we could have our database be externally allocated outside of our application and have our instances connect to our database directly, which that could be a viable solution for the short run. But what happens if we were to do this in other regions? And let's say our database needs to be synced up with each other. How will we go about solving that issue? And don't get me started on what happens if we get even more and more regions of our application up and running. It just becomes a huge mess at that point. It just wouldn't be feasible. So then now comes the burning question again of, would a service mesh be here to save the day? And believe it or not, it actually would be beneficial to have in this case, because we can then have our regions or our applications within our region connect to our service mesh instead. So not only our applications are sort of communicating with the service mesh, but we also have our databases communicating between each other using the service mesh as the medium in between. So it just simplifies how we communicate our application with each other, as well as making our application much bigger in scope without making it too complicated. So shifting gears now, say your application is a microservice. How will we go about having each service stay connected to each other? What happens if a service goes down, and if so, would the other services know about it? This is where a service mesh can come in handy, because service meshes, not only do they globalize all the communication within the application, but they also manage the traffic in between each service, which is very, very important when it comes to managing whether or not your services are up or down. So suppose this service here, suppose we're updating the service, and for some reason the service went offline for some reason. The service mesh would know that the service went down because of how it would do health checks to that service, and would notify all the other services automatically about said downtime. And as a result, would automatically reroute traffic to the nearest service that is still running that does that same sort of thing. So let's say we have another service that will also have the same functionality as the service. All the traffic that, let's say, service 1 would do, instead of going to service 4, it would now be rerouted to service 5. This can also be said for updating a service as well, because if a service, let's say, is down, but another service is up and running that has the same function, the service mesh will automatically take care of it. The services do not need to necessarily understand that a service is down. They let the service mesh do all the work for it itself, which is, again, a very big benefit of what a service mesh does. If we did not have a service mesh, so let's say we don't have this and we have all of our services sort of communicating each other through their own sort of protocol, what would it look like instead? So not only does each service would have to understand when a service that's using goes down, but it'll also have to have some sort of logic coded into it in order to sort of understand how it would redirect traffic it needs to run to the other services. So it just makes things a lot more complicated if we don't have a service mesh in this case, because now the load of communicating between each service is on the service itself, not on an external thing like a service mesh. Plus, having health checks is very beneficial in the long run. So, in other words, if your application is expanding both user and function-wise, it is not a bad idea to look into a service mesh. So, on the contrary, though, if your application is pretty small and standalone, you may not necessarily need to have a service mesh, but again, the decision will be contingent on what your application strives to do. The last major point I want to make is understanding your app security. What I mean by that? What I'm referring to is how confidential is the information being parsed in the application. In a monolithic application, your data is as secure as your inner transactions between each layer. In other words, because of the way how communication is handled internally in a monolithic application, the security is inherently greater in most scenarios. However, in a microservice application, regardless if a service mesh is used or whatnot, all the communication between your services is not within its own self, meaning that the likelihood of information being leaked in your application is greater just because of how it's no longer self-contained as in a monolithic application. So when using a service mesh, you need to properly secure it, just like how all these services are securely communicating with each other if they're not using a service mesh. Because of the main networking role has shifted to the service mesh now, service meshes need to maintain the confidentiality and protection of the data being transmitted between each service. So when you're looking at service meshes, each one of them has different ways of handling security, and that alone warrants enough reason to understand how each service mesh handles their own security. So for instance, Console, a HashiCorp tool, the two main things it uses when it comes to securing its communication with other services is using mutual TLS. TLS, for those that are unfamiliar with it, it's short for transport layer security, and what it does is it acts as a handshake protocol between two entities. So when one service is requesting another service's authentication, it requests a handshake to the other application, and if it receives a proper handshake being a specific certificate and a key, then the connection is secured and thus communication can go through as normal. So Console uses TLS, mutual TLS, and access control authentication, ACL for short, in order to establish security between services. When properly configured, in order to access any of the services in a Console service mesh, you need three things in order to do it: an ACL token, a private key, and a signed certificate that's signed by a certificate authority that Console itself recognizes. And did I also mention the ACL token requires specific Console policies? They have it wired down fine. Another service mesh tool that you could also use is Istio. Istio also handles its security itself by using TLS as well, but they also have something called an end user authentication policy. While it shares some similarities with Console, end user authentication is very different in terms of how you use it and how you set up as opposed to access control authentication. Istio was also built with using Kubernetes as the cluster's orchestration in mind, as opposed to Console, where it doesn't necessarily need to be in a Kubernetes cluster in order to work. So, in other words, when deciding on a service mesh, confirm how it encrypts data in its communications and how it is implemented in your solution. If the data is too confidential, it may not be a best idea to make your communication be external as opposed to internal. To summarize what I covered in today's video, there are 3 key aspects you will need to understand before using a service mesh. First, understand your application's hierarchy. If it is comprised of loosely independent services, a service mesh may be the right solution for you. Second, consider your application scope. If there will be consistent additions to your application, a service mesh could help alleviate some issues regarding updates in the future. Lastly, keep in mind your application security when researching service meshes. Compare and contrast each solution's features before committing into one. With this knowledge under your belt, you are now more informed of how a service mesh could play a part in your application. If you're committed to using a service mesh, there are other types of meshes you can use other than Console and Istio, so please research and look into other solutions before committing to one of those. Thank you for tuning into this video. If you like what you saw, please like, comment, and subscribe to our channel. We are always pushing out new content. We also offer various trainings and various DevOps software, such as Console. So if you're interested or have any general questions about what was covered today, please contact us at this link below. Thanks again, and see you guys next time.